Welcome. Today we will discuss polynomials and factorization of ninth class. We will discuss division of polynomials. We will see one example first. Suppose we have a number 8 and we are asked to divide this 8 with 3. What will you get? So in the normal method, what will we do? We just write 8 in between the braces and write 3. This 8 is called dividend and 3 is called the divisor. So 3 twos are 6. After that, just keep minus 8 minus 6 2. So this 2 is the quotient and this 2 is the remainder. So this is the general method of finding the quotient and the remainder. So for the polynomials also we have the same. So we will see the example 6. Example 6, that is divide 3x square plus x minus 1 by x plus 1. I will explain this in the non-routine method. So for this question, first we will write the dividend. What is the dividend here? The dividend is 3x square plus x minus 1 and the divisor is x plus 1. So we will use the Horner's method, Horner's synthesis method, to find the quotient and the remainder. Actually, this is also called as the Vedic method. In Vedic, it is called as the Nikilam or the Paravartya method. So if you get the negative, then it is called as a Paravartya. If you get the positive value, then it is called as Nikilam method. So let me explain this. First of all, we have to do observe this polynomial 3x square plus x minus 1. This should be in order. Order in the sense, first it should be highest degree. So x power is 2. After x power 2, definitely there should be x power 1. And then after x power 0. That means constant term. So this is the sequence. Definitely we have to observe the sequence. Yes, this polynomial is in a sequence. So first of all, take this divisor x plus 1. So write x plus 1 is equal to 0 and find the value of x here. X is equal to, when this plus 1 comes to this side, it will become minus 1. Okay, so it is minus 1. That's why it is called Paravartya method in Vedic. So this is very easy method and it is not in the textbook, but we can use no problem, because in the examinations also any method is acceptable. So you don't bother about that. Already in the previous 10th class textbooks, so this method is introduced. Actually in the new book it is not there, but no problem, don't worry. So first you should write the coefficients of the coefficients means, so the numbers which are before the variables. So here the coefficient is 3. Here it is. So here the coefficient is 3 and x has a coefficient. So the number which is before x is here nothing. Nothing in the sense it is has 1. And after that try the number. So 3, and after x square term we have the x term. So its coefficient is 1. So just leave some space and write it with the sign itself. We should write plus 1. For the first number I am not writing, but for that also we should write. So it's good to write. And then after we have the constant -1, and we should keep the lines like this. Yes. And here the divisors, actually here what we are doing, here we are finding the 0 of the divisor. X plus 1 is a divisor, so we are equating to 0. That means we are finding the 0 of this divisor, so that is -1. So just keep -1 here, and then after just draw a line like this. First term, for the first term we should take it down first term every time, so no need for you. So whenever you are using this method, so you have to take the first term as it is. If it is -3, then take minus. It is +3, then take +3. In the first step, what we have to do, we should multiply these two. So I will do here. First I will write step 1. There no need to write, but for your understanding I am writing. So -1, this -1 into +3, -1 into +3, that is equal to -1 into +3, minus into plus, minus 1 into 3, 3. So it is -3. So write -3 here and write the answer. +1 -3, +1 -3. What is the answer? We get -2. The next step, for the step 2, we do the same. Take this -1 into, next time this -2, multiplication, -1 into -2, that is equal to minus into minus plus 1 into 2, 2. So it will become +2. And then after simplification, just observe, every time the number which we get in the last position will be the remainder, and the remaining are quotient. So -1 plus 2. What is the answer? Here the answer is +1. So we can write this is equal to R. R in the sense it is remainder. The symbol for remainder is I am writing it as R. The remaining, just leaving the remainder part, and the term or the number which is before this remainder, this is constant term. So write the constant -2, and the term which is before the constant is x coefficient. So observe here, this is constant, and the term which is before the constant is x term, and the term which is before x term is x square. Same, we should follow the same. It is constant, and the term which is before the constant is x term, so that is plus 3x. Yes, so no term is there before +3, so that here it is the quotient. So I will write the quotient. Quotient is equal to +3x minus 2, remainder is equal to +1. So like this you have to find out the quotient and the remainder when one polynomial is divided with another. So let us observe one more example. I will take one more example, that is the textbook itself. So it is example 7. In this, divide the polynomial (2x⁴ minus 4x cube minus 3x minus 1 by x minus 1, and verify the remainder with 0 of the divisor. Yes, so first take the polynomial, that is 2x power 4, and the previously I have told you that the polynomial should be in sequence. So each and every x term should be present. So if you have no term, then you should write 0. So 2x power 4. After x power 4, so we should get x cube. So minus 4x cube is there. After x cube term, we should get x square term. Here no x square term is present. That's why what will we do? Just simply we can write 0x square, no problem. So there is no change in the value. And after x square term, so if any term is not present, then in the place of that term, we should write it 0. So next minus 3x and minus 1. Yes, it's finished. And the next step, what should we have to do? We should take the divisor. And for this divisor, we should find out the zeros for this divisor. So x is equal to minus 1 comes to here 1. So in the next step, what should we have to do? We should write the coefficient of this polynomial. So first write it is 2, and after that leave some space and write the next coefficient minus 4, and leave some space. Next coefficient, x square coefficient is 0. Next x term, that is minus 3. Next minus 1. Yes, now the coefficients been written. Yeah, so it is 1. This 1 is the 0 of the divisor. So for with this one we have to divide, but for the first step we should take 2, same like that only. So for every term, the first time division you should take 2 as it is, and we should multiply these two. In the next step I am not multiplying, I am not writing the steps here, just by own I am doing 1 into 2, 1 into 2, that is 2. So minus 4, this is 2 in the sense plus 2 actually this is. So minus 4 plus 2, this is minus 2. In the next step, 1 into minus 2. 1 into minus 2, that is minus 2. So 0 minus 2, so we get minus 2. And 1 into this minus 2. 1 into minus 2, minus 2. So minus 3 minus 2, minus 5. And 1 into minus 5, minus 5. Yes. Now this last number is the remainder. So minus 1 minus 5, this is minus 6. So this is remainder. So I will write this is equal to R. And the remaining terms are quotient. So first this is, say, just leaving the remainder, this minus 5 is the constant. And the number which is before the constant is the coefficient of x term. So that is minus 2x. And that after x term we get this is x square term. So minus 2x square. And after that this is x cube term. So 2x cube. So this is called quotient. So like this we have to find. And for this question you have to verify. What you have to verify? Let me explain. So first of all, we should write the question first. That is p of x is equal to 2x power 4 minus 4x cube minus 3x minus 1. So here we have to verify this 2x power 4 minus 4x cube minus 3x minus 1 with the 0 of the divisor. This is given in the question itself. And we have to compare the remainders only, not the quotients. So for this, what should we have to do? Take x minus 1. It is a divisor. For this divisor, we have to find out the zeros. So x minus 1 is equal to keep 0, x is equal to 1. Now we have to substitute this x is equal to 1 in the polynomial. So what will happen? P of 1 is equal to 2 into, in the place of x write 1. So 4 into x means 1, minus 3 into 1, minus 1. 2 into 1 power 4 means 1 is multiplied 4 times, 4 into 1 minus 3 minus 1. So 2 into 1, 2 minus 4 minus 3 minus 1. So 2 minus 4 minus 2 minus 2 minus 3 minus 5 minus 5 1 minus 1 minus 6. So this is only the remainder. It is the remainder. So what we are asked, we should compare the remainders only. Here the remainder is minus 6 and here also we got the remainder minus 6. So our answer is correct. And now we will learn the remainder theorem. So what is the remainder theorem? The remainder theorem is, if P of x is a polynomial divided with x minus a, then the remainder is x, then the remainder is P of a. Yeah. So what is this? Yeah, I will explain this with the previous example. Yes, P of x is a polynomial. Okay, 2x power 4 minus 4x cube minus 3x minus 1. And if it is divided with x minus a, x minus a means in the place of a we have 1. That means it is written as x minus 1. Then the remainder is f of p of a. So what I have done, x minus 1 is equal to 0, x is equal to 1. The next step I substituted this 1 in the polynomial p of 1. So observe that. Yes. So if it is a, then what will happen? In the place of 1 you should write a, p of a. So p of a means what we got? Remainder. Yes, this is the remainder theorem. So let me explain one example. Example 9. Check whether x minus 2 is a factor of the polynomial x cube minus 2x square minus 5x plus 4. Yes. So here first we should suppose this as p of x or f of x, no problem. P of x is equal to x cube minus 2x square minus 5x plus 4. Next we should divide this with x minus 2. So we should find the zeros for x minus 2. I will write x minus 2 is equal to 0. For this we are finding zeros. That's why only I kept 0. X is equal to minus 2 comes here, it becomes 2. So if you substitute the zeros of the divisor in the given polynomial, we get the remainder. That's it. That is the remainder theorem. So P of, in the place of x, write this 2. P of 2 is equal to, substitute 2 in the place of x, 2 cube minus 2 into 2 square minus 5 into 2 plus 4. So simplification, 2 cube means 2 into 2, 8, minus 2 into 2 square, 2 into 2, 4, minus 5 into 2, 10, plus 4. So 8 minus 2 into 4, 8, minus 10 plus 4. I will simplify all these together. So 8 minus 8, 0, 0 minus 10 plus 6 plus 4 minus 6. So this is the remainder. Here we can't find the quotient. So with this method we can find the remainder. So what is the question? Finding the remainder is same method. The question is, check whether x minus 2 is a factor of the polynomial. Here the word, this factor, this word is important. So for this I will explain one more example. Suppose we have a number 8. Okay. So you check whether 3 is a factor of 8 or not. That means we should divide 8 with 3. So what we get? 8, 3, 2 are 6, remainder 2. So we can say that 3 is not the factor, right? So if we get the remainder, then we can say that it is not the factor. And let us take one more number. Suppose check whether 4 is a factor of 12. So we should divide 12 with 3. 3 4 are 12. Remainder 0. Yes, we got the remainder 0. So that 3 is called, 3 is a 3 is a factor of 12. Yes. Same way here also, if we get the remainder 0, then we can say that this x minus 2 is a factor. Here we got the remainder minus 6. That's why what will we have to do? We can write that x minus 2, I will write here, x minus 2 is not a factor. So like this we have to find the remainders and the quotients also. For the quotients we have to use the Vedic method or Horner's synthesis method. For the reminders, only for the reminders we can use the remainder theorem. So now you have to do this example exercise 2.3. So I will explain some more questions. Example 11. What is example 11? That is, if the polynomials, if the polynomials ax cube plus 3x square minus 13 and 2x cube minus 5x plus a are divided by x minus 2 leaves the same remainder. Then find a. This is the question. So for this question, what should we have to do? Here we have two polynomials. The first polynomial is x cube plus 3x square minus 13. So when it is divided with x minus 2, we get some remainder. Suppose maybe 10, let us suppose. By dividing 2x cube minus 5x plus a with x minus 2, also we get the same remainder 10. That means both the remainders are same. So for this, first we should suppose this as p of x. So p of x is equal to ax cube plus 3x square minus 13. So in the next step, what should we have to do? We should find out the zeros for the divisor. We are using the remainder theorem. So x minus 2 is equal to 0. So x is equal to 2. Keep this x is equal to 2 in this polynomial, we get the remainder. By substituting itself, it gives the remainder. So I am substituting p of, in the place of x, write 2 a into 2 cube plus 3 into 2 square minus 13. So next, this is equal to a into 2 cube means 2 into 2 into 2, 8 plus 3 into 2 square 2 into 4, that is minus 30. And a into 8, 8a plus 3 into 4, 12 minus 30. Let us do some simplifications. That is equal to 8a plus 12 minus 13, that is minus 1. Here some students will 8a minus 1 means they will write as 7a. This is the biggest mistake done by so many students. Here we should not do that. Why? Because it is 8a. In this we have the term a. It is 1. So in this, if you have a, then we can add or subtract the coefficients. But here this is 8a and this is 1. Both are different terms. So unlike terms, we can't add or subtract. The unlike terms should keep the same. So just 8a minus 1. So many students, they will simplify this 8a minus 1. Yes, they definitely will write, they will write 7. So don't do that mistake again. These are so many blunders done by the students. And this is the remainder. Actually, it is a remainder. I will write here remainder. And we have one more, that is 2x cube minus 5x plus a. 2x cube minus 5x plus a. This is the second polynomial. So for the first polynomial, I kept the name as p of x. So for this, I will write the name as f of x is equal to. And in this also, we have to substitute the same. So f of, what is the 0 of the divisor? The 0 of the divisor is here 2. X is equal to 2 here now. So same, substitute p of 2. So 2 into x means 2 cube minus 5 into 2 plus a. So equal to 2 into 2 cube means 2 into 2 into 2, that is 8 minus 5 into 2, 10 plus a. We will go on some simplifications. So 2 into 8, 16 minus 10 plus a. So simplify, we get 16 minus 10, 6 plus a. Here also, so many students will do some mistake. What is the mistake? 6 plus a means they will write it as 6a. Actually, first of all, common sense is, if you write 6a, then what is the value of 6a? 6 into a. Okay, 6a means 6 into a. But here we are writing 6 plus a. How? So these two also unlike terms. Unlike terms should not be added and should not be subtracted. Just keep in the mind. The next time you should not do that mistake. So here also we got the remainder. According to the question, see the question. If the polynomials x cube plus 3x square minus 13 and 2x cube minus 5x plus a are divided by x minus 2 leaves the same remainder. Yes, here is the word same. So it means both the remainders can be equated. So both the remainders are equal. So just equate these two. Equate. So 8a minus 1 is equal to 6 plus a. So for this, we have to bring all the like terms together. So 8a in the left side and plus a in the on the right side. So bring all these together. So 8a is greater. That's why I am bringing this plus a to this side. So 8a and plus a, when this crossing this equal to, it will become minus a, and 6 remains there itself. 6. Then this the number minus 1 is on the left hand side. When this comes to another side, becomes plus 1. So 8a minus a. So many students, they will write it as 8. 8a minus, then what will they suppose? A minus a, it goes 8 remains. So it's not that meaning. 8a minus a. 8a minus a means we have 8 a's. 8 a's. From that 8 a's, just remove 1 a. So what will happen? There will be 7 a's is equal to 6 plus 1, 7. So we should find out the value of a. So a is equal to 7. This 7a means 7 into 8. So I will write one more step. Sorry. So a is equal to 7. When this 7 multiplying here, when it comes to another side, becomes by 7. So a is equal to 7 1 jar, 7 1 jar. So we get 1 by 1, that is 1. So like this we have to find out. And here the mistakes made by the students are 8a minus a, and they will add the unlike terms and they will subtract the unlike terms, and suppose if we get 7 plus a, then they will write it as 7a. So like that. So don't do those kind of mistakes. And in the exercise 2.3, just complete all the sums. Here we have 9 sums, and complete the 9 sums. So with the help of the Arnott's method and the remainder theorem, we can solve all these sums. Thank you.